Hello, alright, let us start for this talk. In this talk, I would like to talk about American option pricing by conditional Monte Carlo. Our title and topics in these sessions in this presentation are introduction, stopping time and boundary value, collaborating and aggregate Snell envelope for best approximation, book value control variate, criteria measure, and variance reduction method in conditional Monte Carlo for approximation. First of all, introduction. We don't have hardware resource or all hardware resource of the world for compute our derivative pricing, derivative risk, and then we're limited to limit hardware resources for compute the derivative pricing, risk, sensitive analysis, and other problems for solving these problems for financial derivatives. Financial derivatives and a slow CPU in the history is a problem for algorithms to solve this problem. Time saving is another problem. We don't have enough time for compute the dynamic of price change after a time, and we need compute now, just now for this price. Then we use best algorithms for solve this real-time processing, parallel processing, and other techniques for solve PDEs, ODEs, closed form, and approximate numerical analysis for pricing in financial derivatives. The history of financial derivatives, computational financial derivatives, from 1919 came onwards, control variates to now about martingale control variates and European option by scientists Hugh, Grizzly, Kemner, Wurzweil, Boyle, Brodia, Winkliang, and others scientists in this field. They works on often stochastic interest rate, control variates, reduce variance reduction, and improve efficiency in conditional Monte Carlo using jump offing when we have a poison for in Brownian motion, and hybrid Asian option, martingale, and in European and American, and in this talk American option, and other techniques for variance reduction such as importance sampling in portfolio, or fast computing with Fourier or by Fourier transform. The dynamic of these models in American call option is DST mu TST dt plus sigma TST dWt. That dWt is Wiener driven, a Brownian driven, normalized, and mu t and sigma t in a standard form is mean and variance of the dynamic of underlying assets. We need to in this model, our model, an American call option, that sigma t has dynamic, Heston dynamic. That's in equation number 2. D sigma 2t equal minus gamma sigma 2t minus t theta t plus cos sigma t dz 2t. Dz 2 is Brownian standard driven for the volatility of these underlying assets, and it's mean reverting model with a speed of theta and gamma for Ornstein-Uhlenbeck method. Use Ornstein-Uhlenbeck method for modeling the underlying asset that used in American call option. American call option payoff is equal in number 3 equation the maximum of price of maturity date or executing price of American call option tau, each tau between 0 and the maturity date, minus K, which is positive, this price is, else is 0. Similarity that we discount with the rate of R. Discount R, the price of American call option for now price in each time. We use a stopping time and boundary value. The value call option satisfy these 4 equation for bound the price of wild American option approximation. This is a discount of payoff. This is the call between the price bounded between the price of underlying asset and between the max payoff and other, these are equals. For best execution time tau in infinite time horizon between 0 and capital T, we need to compute minimum super martingale dominance on this stochastic expectation that conditional by the price at the last level, earlier level of price T, and that is a function of underlying price J of ST. We talk about it. Tau hat is a optimal stopping time between each stopping time. Let me check it if I have a and when you use this stochastic process, you have time t 0 and time t maturity t, and each tau 1, tau 2, each of this is k, each of tau we need to select. These are not selected because 0. Which of tau is selected? We need the infimum earliest t, minimum t, that max price of American option. That we use alpha J of ST for infimum this stopping time with a Snell push. And earlier we have another, let me check, we have long term R. R means rate, interest rate, bank interest rate of bonds per pair, long term, and we are trying to bound this price. The Snell envelope, let d alpha I alpha belong to A, that be a family of super martingales indexed by alpha, that we have a process xt defined such as equation 11, is a super martingale dominant on X. Here we have dominant. We need to approximate between R and this dominant. Another theorem that we use, consider a process y with expectation yn infinite for all n below maturity date. Then there exists a Snell envelope for y that we convexed and we push and exist good envelope for dominance on y. We need to find this and as a rate of r for compare between r and e, this dominant for approximate the price. The proof is define D as the formula of super martingale dominating y. We define S equal infimum of family of this super martingale dominant infimum of Dn, and we have the minimal super martingale constructed for this topic. We have a heuristic technique for model. When the market we use premium discount of bonds, we have these techniques. This is a coin, head and tail. When we have gamble, the market gamble is two-sided. When the market is uptrend and when the market is downtrend. Downtrends we have bond. Uptrend we have stock or S. Both for hedge the market, American call option market, we use S and B. The mixing strategy between S and B, buy S, buy B, sell S, and both opposite of the coin. We model the rate of when this preview when we have uptrends in American call option payoff. These are payoff, all of positive, negative, positive, negative, positive, negative. Positives are is modeled by a stock such as here, and negative bond we use fixed income market, the rate of R. These are bond, we model is book value in the arithmetic progression, payment varying in arithmetic progression. For modeling the annuity, it's separate two process. Up is a stock, down is bond. Up is a stock, down is bond. Number 15 and 16 is the simple formula for calculating these downtrends payoff with bond. We model and separate the model of American dynamic with two dynamic, book value of bond plus book value of underlying asset of ST. Payment varying in geometry progression, such as when we have a Snell push for downtrend curve that conjunction with the price of payoff in the period in long term, no short term, in long term. And book value here is book value R and P. P is S, and R is bond, that in the last slide. Book value in number 20 is CGAN minus T and CBIN minus T for bond book value in the market, in the terminal, in the people that sell book value price of each level. And for compute the variance reduction, we need to variance reduction between this book value and the variance of dynamics of American. These have a sigma and have a book value. These are book values, and we need to correlation between them for variance reduction the price. Such as in this slide, you see book value and interest rate that return minimum to the interest rate, long-term interest rate. When your option, such as in this diagram, when you and long term, these are return or relation to long term. These long term and these long term. Then we need to model and approximate the price with Snell push. For simulating and estimating method in this paper and research, we use Ornstein-Uhlenbeck process such as 22 and 23. 23 is Heston model and and Ornstein-Uhlenbeck theta sigma, and number 22 is standard Brownian motion with the Ornstein-Uhlenbeck and Heston model. Discretization for approximation in MATLAB or Python. For variance reduction and criteria measured in conditional Monte Carlo, we use the expectation of Y process conditional double condition is equal, and for variance reduction we need to remove one variance, one expectation, and we have line 3. If we can reduce the expectation of Y condition by X here, this expectation, then we reduce the best price approximation for Y. Here we have these types for variance reduction of two sample paths. Sample path 1, sample path 2, for example. 1, 2. And in perhaps in K payoff we have tau 1, tau 1, tau 2, and each of sigma 1, sigma 2. We have criteria measure between sigma and tau. Which of them is best criteria measure? If sigma 1 lower than sigma 2, or tau 1 lower than tau 2, it's better. But if sigma 1 is lower than sigma 2 but tau 1 is greater than tau 2, which of them is better? Then we need optimizing by the 25 or fraction. Each tau is lower, r is greater. We have two methods for criteria measure. We used 2 or 3 criteria measure for solve the approximation. In 24 and 25 we use the product of tau and sigma as a criteria measure, as a measurable criteria measure for reduced tau, reduced increase sigma, or in 23 and 27 for comparing the payoff fraction by tau. We need execution in lower tau for best execution and best strategy for execute and exit from the American option. Apply these two lemma. These are related. The function by t. These two criteria measure are the function of t, and r2 is a function of t. Then we can, and it is continuous because sigma is continuous, because the time is continuous, that we have derivative and ito lemma on both of criteria measure 1 and criteria measure 2, and equal to 0 for best point for change the gradient of these two. In 29 you see the best approximation based on variance reduction method. One of them is CMC. We use CMC. You can use importance sampling for this method and these two criteria measure, and you can use other techniques, importance sampling, other variance reduction techniques. By two variance criteria measure, you have 3 price, number 30, 31 and 32. S minus K is the simplest. Discount of rate, long term rate is another price, and ergodic of tau, which tau, that tau is in number 24 or 26. We have 3 price estimation. In this slide you see more long-term interest rate, family of interest rate or bonds rate for free coupon bond rate for modeling in the market, for other bonds such as these, one of 6 months, 3 months, or other. Red line is the K, the cloud of Brownian of ST, that below red is 0 and top is the st minus k. St minus k. Here is another color we used, st minus. Here is rt minus k. Here is st minus k. Here is one another rt minus k. Here is st minus k. And here is let's check it. Here is here and here. Exaggerate. Here is S, here is bond, and in the residual. And you see the familiar SNL push that in the first slides of this presentation simulations. We have two sequences from these three simulations. We have two sequence from the discounts of payoff minus discount of execution payoff, number 33 and 34, the sequence of payoff. These two sequences differentiate in the long term when m to finite, in convergence theorem, log convergence theorem, is the price of American option VMT. This is the formula for approximation between the bond, between the long-term interest rate or bond, and the sequence of st minus k is number 34. These differentiate limited to the price approximation for price. These are reference: Boyle, Soddy, Smith, Bouchard, Loft, Brodia, Longstaff, Snell, and Kratzels. Thank you for consideration and goodbye.